One of the most important gas laws in chemistry is the ideal gas law, and our equation is going to be PV is equal to nRT. A lot of times it's written in cursive for the N, it's not an M, but if you want to write it just regular, that's fine too. So what does that stand for? P stands for pressure. Our normal unit for this is going to be atmospheres, or ATM. However, you can use other values. If you use other values on it, you're going to have to use a different value of R. V stands for volume. Now, in our other gas laws, it hasn't mattered whether it's been in milliliters or liters. However, based on the constant, you'll see here that this is written in liters here, so it has to be in liters. N stands for number, and that's going to be in moles. So that means that sometimes they're going to give you grams, and you'll have to convert for moles, or they might even ask you to find the molar mass. R is the ideal gas constant. And the one that we'll usually use is 0.0821. The label for this is liters, atmosphere, mole, Kelvin. However, with other problems, they can use kPa or different things. There'll be different values. I'll show you a different kPa value and how you could use it. But something else you could just do would be convert it. Temperature, as you probably guessed, needs to be in our favorite scale in the gas laws, which is Kelvin. And again, to kind of help you see these, you can look at these labels on the value of R, and that will help show what your units need to be in. Okay, so you're always going to know R. It's a constant. It's going to be the same in each problem. You'll be given 3 of the variables and solve for the 4th, plus you know R. So you'll know 4 of the 5 things. Again, make sure everything is in the correct units before you start. Okay, so let's look at a sample problem. So again, our equation is PV is equal to nRT. So we're going to figure out what we know here. So you see here what pressure. That means P is our variable. For V, we know it has to be in volume, and that's in liters, so that's already in the correct unit. N is moles, so 3.0. R we always know, 0.0821. And then T, and it's already in Kelvin, so that's good. So we're going to go ahead and plug this in. You want to multiply out the side that you already know everything on, which this time is the right side. If you want to write out what the sides are and say like 2 times P is equal to what the other side is, which would be 3 times 0.0821 times 300, you could go ahead and do that. I would just write out the side all the way multiplied first and then divide it. So when I do this on here, what's the pressure of this gas here? My least number here is, for sig figs, is 2, so I'm just going to round this off to 2. So it's 37, and again, pressure is in ATM, so pretty high pressure here. Okay, so again, you know R, you know 3, solve for the remaining 1. Okay, with grams, you're going to have to convert first. So in this one, we are going to know the pressure here. So again, PV equals nRT. So now it's 1.0. My volume, I'm looking for the liters, 2.5. I don't know N. N is going to eventually help me get my mass here, but I don't know it yet. And then my temperature here, already in Kelvin, 298. So this time I know everything on the left first, so I'm just going to do 1 times 2.5. And then I'm going to divide it by 0.0821. And divide it by 298. Again, my least sig figs here is 2, so I have 0.10 moles. But I'm not quite finished yet. I want this in grams, so I'm going to have to add up 1 C and 2 O's. So that is 44.01 grams and 1 mole. Again, use dimensional analysis to cancel out. And so that's just going to move my decimal over 1. And it'd be 4.4 grams of CO2. Sometimes they might give me grams first, and then I'll put it in moles, and then I can plug it in for N. Other times you're going to have to use the ratio of the grams and moles to find the molar mass. Okay, so if we have R that's in kPa, you could use a different value of R. It's 8.31. So I'm going to solve this the first time just leaving it in kPa. So my pressure is 88.2. I want to find my volume this time. I have 3.23 moles. I'm going to use R as 8.31 this time, and then my temperature is 443. So I'm going to take 3.23, multiply it by 8.31, and then also multiply it by the 443 Kelvin, divide it by 88.2. Then I'm going to go ahead and get my answer. All of these have 3, so my volume is 135 liters. Let's say I didn't know that value for R, I didn't have it handy. I could go ahead and use my pressure standards here. So I know that 88.2 kPa, if I converted that to atmospheres, I'd use their standards. So I can take 88.2 and times 1, don't really have to put that in your calculator, divided by 101.3. And I'm going to get 0.871 ATM. So that's P, still don't know V. N is still the same. R, I'm going to go back to my original value, 0.0821. And then 443 is still the same. So I'm going to take 3.23 times 0.0821 times 443 and then divide it by 0.871. And here I get the exact same answer, 135 liters. So either way would work here. Okay, so you're going to go ahead and practice some of these. You're going to be looking for different values. Again, watch out for liters, has to be in Kelvin. The ones I gave you are in atmospheres. I think I gave you one where it's in kPa, where you could do either of these as well. And then just watch your labels.